Alright guys, now I'm going to work through a couple practice examples with speed and velocity. We're going to look at a few velocity examples and then one speed example to show the difference. So I like to use this little diagram to help us out. We have a little ice cream truck where we can actually move this ice cream truck around on the screen. Okay, he can move forwards, he can move backwards. I don't really like his position right now, but we're going to work with it. Okay, so up in the top, I have a reminder that speed is total distance over time and velocity is final position minus initial position over time. So here's our example. We're going to pretend that our ice cream truck starts. We're going to pretend our ice cream truck starts at 0 meters. He travels forward to 10 meters and then backwards again to 5. So this is a 10-meter change, and this is a 5-meter change. His time forward, let's say this took him 20 seconds. He was moving really slowly because he wanted to make sure that all the kids had a chance to get ice cream. And the time that he took to back up took 5 seconds. So we're going to calculate a couple things here. We're going to calculate what was his total velocity as he traveled forwards, what was his velocity as he traveled backwards, what was his overall speed for the entire amount of distance traveled, and what was his overall velocity for his total displacement. So starting with velocity forwards, he started here and ended here. So forwards, if we use our equation of xf minus xi over t, his final position was the 10-meter mark. So 10, his initial position was 0, over 20 seconds. 10 over 20 is 0.5 meters per second. Okay, his velocity backwards. If we use the same equation of xf minus xi over t, his final position was 5, his initial position was 10, and that took him 5 seconds. So his velocity as he traveled backwards was -1 meter per second, because 5 minus 10 is -5, divided by 5, which is -1. Okay, so now we're going to look at speed. His speed is his total distance traveled divided by the total time it took. So his total distance traveled was 10 meters forwards, 5 meters backwards. That was a value of 15 meters. And it took him 25 seconds. So his velocity is 15 divided by 25, which is 0.6 meters per second. Now that is a different number than 0.5 and 1. Now his total velocity is his final position minus his initial position over the time that it took. His final position, where he stopped, was at 5 meters. So the velocity is 5. His initial position, where he began, was at 0. And it took him a total of 25 seconds. So this is 5 over 25, which is an overall value of 0.2 meters per second. Okay, so you can see that these numbers are very, very different. Velocity forward was 0.5, velocity backwards was -1, so he backed up pretty quickly. His overall speed was 0.6, but his total velocity was only 0.2 meters per second, because he really only had a displacement of 5 meters, and it took him 25 seconds to achieve that displacement. So be careful when I'm asking you questions, because if this is a prolonged trip or lots of turns or lots of norths and souths and then easts, you're going to have to break those apart overall, and you may have a different velocity than what you think. But again, once we get a handle on this, there will not be very many trick questions as we move forwards. I just want you to make sure that you articulate the difference between speed and velocity, distance, displacement. Now, when I see you in class next, we're going to sit down and actually practice with these equations. We're going to do some math, do some rearranging, and solve for unknown variables. So that's where we're headed from here. See you guys soon.